Hey guys, and welcome to the second part of the quantum computing tutorial on this channel. In this video, we are going to be actually designing a quantum circuit with Qiskit. So over here, what I want you to do is open up your terminal. On Mac, you can just search it up on your Spotlight. Just search for terminal and click on it, and it should open up the terminal for you. In Windows, you should have that search bar. In Linux, also in Activities, you just have to search it. Once you're in your terminal, what I want you to do is just type out pip3 install Qiskit. You need to execute that command. I'm just going to do that for you. Then you also need to install Jupyter. So Jupyter is used because we're going to be running this in the form of a Jupyter notebook and not on a local machine. So what I want you to do is over here just type out ls. I'm just going to go with cd to my copy that, paste it, and cd to one of the directory. So I'm gonna computers, so I'm gonna copy that back, paste it. Now over here just type out Jupyter, and you want to create like a new kind of a new Jupyter notebook. So that's what we're gonna be doing. So we're gonna do and type out Jupyter, uh, Jupyter -n quantum computing. Bye. Actually, I think it's just this much. Jupyter. Just a second. Let me have a look at the command. I think it was just only. I was having some issues with Jupyter. Quick look over here. And let me have a quick look, and I will be back. Okay, I figured it out. Anyway, also you need to do an pip3 install Jupyter lab. You also need to run through that. Okay, and you don't need to put the space button. And now what I want to do is just have a Jupyter lab. So that's all we need to do. So it should open it up. I'm just gonna minimize this terminal, and it should open up it on your default browser. In my case it's Chrome, but in your case it can be anything else. So you should be going to this localhost link. Okay, it takes a second. I'm gonna create one of Python 3. So it should be called untitled.ipynb. Just go to file, click on save notebook as. So I'm just gonna call it quantum computing computing.ipynb. So over here, all you need to do is type out import Qiskit ask you, and what we need to do is just run this. Now when you run this, if you do not get any error, then that's good. Now some people, what they do is just type out from Qiskit import star. You might have seen some people do that, but I don't really like to do that, but that's just me. So now what we need to do is we need to make a quantum circuit. So quantum circuit is going to be the circuit which will actually be containing the qubits. But before we do that, I'm just going to really, yeah. So what we do is just type out circuit equals to a quantum circuit of 2 by 2. So it should have like 2 classical bits. So making a quantum circuit with 2 bits. Now since we are dealing with quantum computing, I know it will be kind of painful for you as a Python programmer to actually dealing with bits, because Python deals with all of that by itself. But whenever dealing with something like quantum computing, we have to deal with the things that are really small, like bits. So once you do that, I'm just gonna run this and see what happens. Now, okay, quantum circuit. Okay, it has to be quantum circuit, I guess. Yeah, there we go. So we have to make this. So we have made a circuit. Now what we need to do is we need to actually put something. So of course right now if I just go ahead and do something like print out the circuit, you will see what happens. So you can see right now if I just print out the circuit, you can see it says uh, qubit 0, qubit 1 and qubits actually 2 qubits or classical bits, qubits. Now what we need to do is we need to add some NOT gates and stuff to the circuit. So basically what a NOT gate is, it will flip the qubits and like it will get that. So if the qubit is a 0, it will flip it. So let me actually show it to you. I'm gonna make a comment adding a NOT gate to the quantum circuit. Now, these areas, it's very difficult to understand what's going on. If you rewatch this video twice or thrice or more than times, you will understand what's going on. If you do not understand, I think I will link to some sources which are not my videos, obviously, in the description. But if I forget to do that, the thing is, there's this a awesome YouTube channel called Centedex. He's solely like a Python guy. He's like a real pro in Python. So if you have any kind of like things that you don't understand over here, you can definitely check out his channel. You need like this entire tutorial series is like inspired by his tutorial series, so that's why. So we are gonna be adding the NOT gate to the and to a 0. So it will now become like a like currently it's like a 0 and 0, but now after we add the NOT gate, it will become like a 1. So it will become like a 1 and a 0. Because what we are doing is currently what we are doing is by adding a NOT gate, we basically flip the circuit. So in this case, we are flipping the 0. So right now, before this, it was something like 0 by 0, but after this, it's something like 1 and 0. I think I'm correct on this. If I'm not correct, you can definitely comment down below, and I'll be happy to correct myself. So I'm just gonna take this line, paste it over here. So now what we need to do is we need to add like a controlled NOT, so a C NOT. So what we do is we basically a C NOT will like take that new thing and and then it will just make sure that the positions are that. So kind of like that. So we will only flip the second qubit if the value of the first qubit isn't 1. So in this case it will be 0, obviously. So I'm just gonna do adding a C NOT controlled NOT. So we just have our circuit dot C NOT. Also guys, if you are finding this code a bit difficult, I will show you how you can make quantum circuits without writing code through that graphical drag and drop method. It's not that good because you will probably need to memorize a lot of symbols and maths. Like code is the best way you can do it, but just in case of you just can't get past the code, that's one thing. Now we're going to be actually doing a very important thing called measuring the actual things. Now I would not recommend you measure your quantum circuit unless and until you really have to measure it. The reason is measuring can cause the drop, like the if you know anything about quantum mechanics, you know the Schrodinger wave equation. So the Schrodinger wave equation will state the probability distribution of the electron in the quantum system. I know the words are very long, but trust me, that's how it works. So what happens is it will state a probability distribution till now, but as soon as we measure it, the Schrodinger equation will collapse. So right now, all of these are in a quantum superposition, the Schrodinger cat, which I had explained in the last video. If you haven't seen that, go check that out, or you will not understand a lot that I'm doing right now. So the Schrodinger equation will collapse into like one thing. So currently it will be like a wave, but as soon as we put that dot measure thing, it will collapse. So you do not have to every time after everything that you do you have to measure the thing, because quantum computers are made so that the things is measured at the end and we can do all of that stuff pretty quickly. But that's why. So please, if you are actually dealing with like a real life project with quantum computing, I don't think like a lot of people do that. But if you are doing that, do not measure it constantly, cause it's not a good practice. That's all I just want to say, I think. So I'm gonna be measuring the quantum circuit. But the reason why I'm measuring it right now is because for this, we don't need to again continue anything. So that's why measuring right now is the best choice we have. So what we do is just about circuit dot measure, and what we do is just about 0 1 0 1. Now you guys might be kind of like confused, what am I doing here? So like mapping the quantum bit to the classical bit, I think. So that's what we are doing. So we are like mapping the stuff. Now what we're gonna be doing is we're gonna be what's happening? Yeah. Now what we're gonna do is we're gonna be drawing the quantum circuit. So what we do is just type out circuit dot draw. I'm just gonna run this program and you will see what this is. So you can see what we have done over here. So we have our bits and stuff over here. So we have the 0 and the 1, and we have basically just drawn the circuit. Now this is a very simple quantum circuit. Like, let me actually do something. I don't think if this will work, I'm just trying it out. So you can see when we are doing 4, this thing is changing to 4 qubits. So on the first 2 qubits we have the x's, and then that, then we have this and that. And like if I change this to something like 10 by 10, which you can see it's a much bigger quantum circuit. So what I can do is copy this, paste it, and you can see we have more C nodes. So I'm flipping it every time. And if I can also go ahead and like take the circuit X and that. So the NOT gate, and just have 1, and again to like a 1. So now we have created like a much more complicated kind of a quantum circuit. Obviously, I know it's like very difficult to understand what's actually going on over here. So you can see if I add a 1 and I run this, you can see all of these will be gone to a position of 1, and the NOT gates will be also be over here. Whereas if I'm adding a position of 0, you will see it will be on the top. You can see they are on the top. So that's what I'm trying to uh, get to here. So I'm gonna get rid of all these C nodes. It's just gonna be making a very simple quantum circuit. We're not gonna be doing anything complicated. So I'm just gonna reduce this to 2 by 2. We are not gonna be doing anything complicated. That's what I said. So we're not gonna be dealing with those huge quantum circuits. This is what we're gonna be dealing with. So now we have made our first quantum circuit, and well, you can be happy. Now what I want you to do is I want you to go over here and just search for IBM Q experience. So for that, and we can actually run this on a quantum computer. So you have to sign into this. That's one thing you need to do. So once you sign into this, go over here and go to, what's it, dashboard? Actually no, CMO. Now what I have over here is, now do not give this API token to anybody, because this API token is kind of like it's a secret token. So do not give it to anybody. I don't want anybody to see like my API token, but I think I'm gonna show it to you. I don't know. So the thing that I was talking about, that we can actually create these quantum circuits without any code, is if we can go ahead and we can like create a circuit. So like, let me show it to you quickly. Quantum lab, and over here. So over here in circuits, so we can actually create these new circuits. Now, like you can see, here's the code for that. Just go to Qiskit. So that's what I'm talking about. Now, I'm not gonna be really doing with that graphical interface, because you could see we had all of those very kind of like symbols kind of things, which you know kind of intimidating. So now what I'm gonna do is I'm gonna from Qiskit I'm gonna import IBMQ. So IBMQ will allow us to actually access the quantum computer that we have designed after. So now what we are going to be doing is we will actually be taking a secret token that we had over here. So the API token. So when you will actually sign into Qiskit, you will actually get that API token. It's a unique token. So like you won't have like a same API token. So I will probably blur out the part where I will actually be placing the API token, because I don't want everyone from the internet seeing what my API token is. So what we do is just about IBMQ dot save underscore count, and we basically need to place our API token inside there. So I'm just gonna blur it out right now. So you can see I've just blurred it out. I'm just gonna put in my API token over there. My dashboard, see more. Click on copy token. It will show you that the token was copied. And once you do that, you simply need to just paste that token. You don't need to do anything else. And yeah, that's all you need to do. And probably I think I should kind of like do something. Okay, there we go. So I placed my API token. And you should probably get something like this. Something like this, or anything like loading or something. You should get something like that. Now, I'm not gonna show you that token, cause yeah. So now what we need to do is load in account. I'm just type out IMBQ dot load underscore account. Okay, IMBQ is not defined. I forgot to run that code block. Okay, that's quite bad. Okay, run this again. Oh yeah, I'm gonna blur it out again. Blur out my screen. I can't really show like a lot of the things that I'm doing right now. IBMQ. Okay, I just misspelled this. IBMQ. IBMQ. There we go. So if done correctly, you should get something like this. When you do IBMQ.load account, I think I just showed it to you for a second. Whatever. So you get this. If you get this, you're good to go. Alright, so now what we need to do is we need to actually kind of like get a provider. So we just type out provider is equals to IBMQ dot get hyphen provider, and inside we are just going to type out IBM hyphen Q, and I think we need to do that. Nothing, no. So now what we need to do is we need to get the backend. So like this, now this is like some basic code. Like this is some basic like IBM like Qiskit code. So not this. This does not have like an explanation. So I'm just gonna type out this code. And also, I don't think I will have this on a GitHub repo, but I'll try. Then we just put in a try and an accept block. The reason why we do try and accept, because we don't really know if that's gonna happen, so we need to do that. For now, I'm just gonna pass it out. Put in my try block. So what we do is just about qubit count, qubit underscore count equals to the length of the backend dot properties dot qubits. Otherwise, what I just want to do is just about qubit. I just want to copy this, paste it here. Is equals to simulated. Now what we need to do is we need to actually get the names of the backend. So the servers, the quantum computers that are actually running. I'm going to type out print, and I'm going to print an f string. Now if you don't know what an f string is, you can basically, it's like that these ticks in JavaScript. So like we have that back tick in JavaScript, so that's like an f string in Python. So just type out backend dot name. So you can do stuff like this, and we don't need to put the plus sign. Has backend dot status look. Okay, I didn't mean to open my code. Let it. Quit. Okay, there we go. Backend dot status dot pending underscore jobs queued, and we need to get the qubit count. So qubit count. So qubit. I'm just gonna copy this. I'm not gonna count that. Qubits. So we just get the number of qubits, and we basically have to get the server with those qubits. Okay. Account provider object is no attribute backend. Okay. It's back ends. There you go. So you will see what happens now. Okay. It takes a second. Now you can see we are getting this. So it has 0 cubed and 5 qubits, and we have these three things. So we have a first one is a simulator, the second one are the backends. Okay, so we are still having some more. So we have Vigo, Melbourne, X2, and Chasm Simulator. So we have these two. Now at this point, you should be having some sort of a patience. The thing is, in IBM, these quantum computers are actually shared. So a lot of the times, the code that you're going to be running, there are going to be people who are also going to be running the code. So you are going to be like in a queue. So when you're actually dealing with these quantum computers, unless and until you own a quantum computer, which I don't think anybody does, so unless and until you own a quantum computer, you need to actually stay in that queue. So if you actually have like at a long queue number, go have dinner, have a bath, like have a lunch, whatever, because it will probably take a lot of times. So now this is run now. So now what we are gonna be doing is actually gonna be doing some cool stuff. So let's just have a look at one of the things. So I'm just gonna take which one do we take? We can take this IBMQ Valencia. This one looks good, I think. Copy this. Yeah, I think Valencia is good. Now what we do is we just type out from Qiskit dot tools dot monitor. Now at this point, I think this will not work on my computer, but it should work on the machine that you are working. I think there's I made some issues in installations, So it won't work in mine, I think, but it can work. Like there's a chance it might work. There's a chance it might won't. Just type out backend equals to, and we have to get the like have to get this the backend of the IBMQ Balenciaga. If you understood what I'm trying to get. So that's the thing. Now the thing is, why are we using the like the uh, simulator? So that's one thing. So what the simulator will do is it will like kind of like simulate that quantum environment. So let's just get that. So I'm gonna take IBMQ Valencia. I'm gonna copy the name. Then we just type out provider dot get underscore backend, and just gonna put the backend. So IBMQ Valencia, and then we just type out job equals to q dot execute. So execute, so execute the job. We have to do it on the circuit, and we get the backend as, so that's just a parameter we need to pass. So backend and shots equals 500. So these are just some parameters we need to pass in. And then we just type out job dot job underscore monitor. Just gotta get this guy, and we need to monitor job. Okay, let's see. So now job status job is queued. Now the thing is, I'm queued at a status of 2. Now you guys can be queued at a status of like 5 or 6 or 10, anything. Like when I was actually using this, there was actually no queue, but now like there are a ton of people who are experimenting with this. So we are at the second part. So like after the 2 people, like it's gonna be our chance. So that's one cool thing. So like we don't have to wait for a really long time, but it can take a while. So if the first guy is running like a very heavyweight thing, we could take a while. So at this point, if you are running at a very long queue, go have dinner. It will probably take a while. So yeah, you don't wanna rush when dealing with these quantum computers. Okay, so that's one thing. So I'm just gonna write some of the code. So I think this code will not work on mine, but it should work on yours. So from Qiskit dot visualization import plot underscore histogram. So just to visualize it, and from matplotlib import start. Next what I'm going to do is just type out actually I'm not going to be doing that. Now you want to, actually I don't think you're going to be needing this. If you're running on a dark themed editor of this, what you want to do is just type out style.use dark background. So dark underscore background. You would want to do that because otherwise you won't be able to see what's going on. So just type out result is equals to job.result, and now what we need to do is we need to like get the counts, so the number of counts are not quantum bits on the circuit. So we type out counts equals to result dot get underscore counts on the circuit. So we are referring to the circuit that we have made. Have a look over here. Okay, now we are at the first one. We should get the thing in a second. So now let's just plot the histogram. So I'm just gonna make some comments getting the result and the counts. And I'm just gonna be making some more comments over here. Getting the backend. And okay, there we go. So job is successfully run. That is what we want. Monitor the job real quick. So plot the histogram. Plot. So we just have our plot underscore histogram on actually yeah. And do it on the counts. And we want the and I think that is all we need to do. Let me have a look. Visualization. Oh yeah, why have I made this? Okay, I think that comma was just neglected. I guess just do it again. Yay! So the thing is working, and we got the probabilities. Let's go. So the thing that we have over here is the probability distribution of the what do you say the quantum bits. So now we finally have it. So we got the counts, and that's pretty cool. So we get it that the most common response was the one which like the we were supposed to get, but as you can see we also got the same some 0 and some 1. So that's because there's quantum noise. So everything in quantum physics is like it likes something like a noise. So it's just some sort of like a distribution. uh, like I'm sorry, not a distribution. Like it's like a disturbance. So it's kind of like a disturbance that is caused. uh, so that's why. So the, so like if there is a place where all of these quantum things are stored, uh, there can be sometimes there can be like some sort of disturbances over there. So not over here in the IBM Valencia, and that can cause this noise, so it's affecting over here. So that's why you will see that all of these quantum computers are stored in like very preserved places, and not they're not just lying around like at the bottom of your desks. Although of course they're pretty big and pretty fragile, I guess. So even if there's like a change in temperature, or like a little dust particle or a little particle of ice like whisk past the quantum computer, you will see the effect in the performance over here. So like it's a pretty good. Still, the noise is not that much. Like if you will actually look at it, sometimes there are a lot of noise. We're actually lucky enough that we don't have a lot of noise. That's pretty good. Yeah. So we successfully have made. The reason I'm skimming over so quickly because I don't want you to look at my API key. So yeah. So we have successfully executed a task on a quantum computer. So you can like put that in your resume, quantum computer, whatever. Now, uh, you have finally made like a quantum computer. Now we can do a lot of things with this. Now, we there are like a lot of things in quantum computers. So like we can not only we can add like the x, we can also add like other things. So instead of x we can replace it with a h, but and we can do like a lot of things, but I'm not going to be covering it in like this video. It's called the Hadmon gate, and it's like it like puts the qubit wherever you pass it. Like if you pass it, it's in gonna be in a superposition. So we pass it to like a zero, so it will be like in the zeroth or that index, something like that. I guess you think you get it. So this was just a very, very basic kind of a quantum circuit and a little quantum program. You can go pretty advanced with this stuff. Like, you can do that, but you know, uh, it's up to you. So I hope you enjoyed this video. I don't think I'm gonna be putting in the advanced of quantum mechanics and quantum computing in this series, and I could just end. I'm gonna end the video series over here. The reason why I'm doing that is because it will get very, very complicated as and when we get closer like that. And till now, like, I've just posted a few videos on my channel, like 42 videos, and I don't think like all of the people watching my videos are like total advanced people, so you guys won't really understand a lot of the code that I will be writing, and I don't want that to happen. Even the quantum computing, I try to explain you the best I could, but obviously, yeah. So I hope you enjoyed this video. It took a great amount of pain to make this, because I had to learn a lot of this stuff, and it took me a lot of time. So I hope you enjoyed this video and probably this series. Yeah. uh, if you want some more quantum programming tutorials, you can comment down below. I will look into it and make a video on that. If you want to see a machine learning video, I actually created a very cool machine learning project these days, and I also created interfaces for that. So if you want to have a look at those type of videos, you can definitely check a comment down below, and I will make that tutorial for you. If you want some game dev tutorials, I will look into it. I don't know why I've been having an issue with Pi game these days, so that's why. So any comment tutorial, just leave it a comment down below if you want. Text classification, I'm still working on it. Take some time. I'm working on an R and N tutorial, but it will take some time to come. So uh, that's it for today, guys. I hope you enjoyed the video. If you did, like and subscribe to the channel, and I will see you in another YouTube video.